So today we're going to be looking at solving for angles in a right triangle. This is the first time we've been able to do that, right? Up to this point, all we've been solving for are sides. But we can also, using trig ratios, sine, cosine, and tangent, solve for angles. And so if we look here real quick, example 3 asks us to find the measure of the indicated angle round to the nearest degree. So part A says, what is the measure of angle A? So here's the angle we're trying to find. We want to know what is the measure of angle A there. All right? Well, if we're trying to solve for angle A, that means our angle A is going to be like the x. We don't know what it is, so I'll call it x. Okay? Now, with the information that we have in this triangle right here, we have this side, and what would we call this side? Is that the opposite leg to x? Is that the adjacent leg, or is that the hypotenuse of? So it's the opposite, okay? That's right. So if you want to label it that way, you can call it opposite, or if you just remember that, that's fine. And then what is 36 in relation to the x angle there? Adjacent. So which trig ratio are we going to use here that relates opposite and adjacent together? Which trig ratio has opposite and adjacent in it? Tangent does, that's right. So normally we'll say tangent of the degree here, but we don't know the angle measure. So we'll just say tangent of x is equal to the opposite, 19, over the adjacent, 36. And now we kind of might be stuck, right? If we look at this, right, because we don't know how to solve something like this. We have tangent of x. There's our variable. There it is. And we want to get that variable by itself. But how do you get rid of just tangent? Right? Because it's not tangent times x. Some students look at this and they say, oh, well, Mr. Whitmire, the tangent is written next to the x. That means multiplication. So if I divide both sides by tangent, then x will be by itself. Not quite, because this is not tangent times x. It's tangent of x. And so we have to do something. We have to do like the opposite operation. What is the opposite of tangent? Well, let me show you here real quick. 1 second. Let me show you. So the opposite of tangent, okay, is on your calculator. Actually, it's not one of the trig functions. It's like one of the trig functions here on your calculator. So if you guys look at your calculators, okay, you look at mine real quick here, you can see the sine, cosine, and tangent buttons, right? But then above those in different lettering, so mine's blue, some of you might have yellow lettering depending on your calculator, okay, you'll see these trig inverses. So that's sine inverse, cosine inverse, tangent inverse, right? And so the opposite of tangent, what undoes or what cancels out tangent is the tangent inverse. Okay, that's what that little -1 means. We read that as tangent inverse. Okay? And so to solve this, we're going to rewrite this as, well, actually, I'll put it right down here. X equals the tangent inverse of 19 over 36. It's really easy. We're just basically going to use our calculators here. So 19 divided by 36, we type that into our calculator. Okay, hit enter. And that's our angle measure. Okay? And we'll say that's approximately 27.8 degrees. Okay? That's it. Actually, it says round to the nearest degree. I apologize. We actually want to say 28 degrees there. Round to the nearest degree, so 28 degrees. Yes, Ikeva.
So why don't you use the 90 degrees?
We don't use the 90 degrees because if you think about our trig relationships up there, Ikeba, the 3 sides that we're concerned about, okay, are the opposite leg, the adjacent leg, and the hypotenuse, right? If we pick the 90-degree angle to use for like sine, cosine, or tangent, either one, okay, let's just say, for example, we want to do the sine of 90 degrees. Sine of 90 degrees would require us to use the opposite leg, but there is no opposite leg to the right angle. It's the hypotenuse is the opposite side. And so it's like, well, should I use the hypotenuse then, or should I use another leg? But then I'm not using the opposite leg. So like basically our trig ratios kind of fall apart when we're using sine, cosine, and tangent in these right triangles. Now, later, if you like pursue more in your math career, like, you know, maybe algebra 2 or pre-calculus or something like that, or algebra 3, whatever that may be, you will end up taking the sine of 90 degrees, cosine of 90 degrees, and tangent of 90 degrees. Right now, with our understanding of it in terms of like right triangles, it's not going to make a lot of sense how to find those. But later, when we talk about angles on like a circle and stuff like that, not in our class, but in another class, it'll make more sense about why it is what it is. We can do it. I mean, here I can type in sine of 90 degrees, and you get, it's 1. but it doesn't make sense why it's 1 necessarily.
Okay, so then, can you maybe calculate?
Yep.
So when you're doing tan x,
Yes.
and you're putting tan -1 in your calculator because you don't know the angle measurement.
Right. Whenever we want to get the x by itself, the way we do that is using that second tangent, if it's because it's tangent there. So second tangent gives us that, lets us cancel that out. All right, so let's try another one here. Let's solve for angle B. All right, so here's angle B. I'm going to call this angle, we'll say that's y. Okay, we'll say that's y, just because it's a different value. All right. So let's set this one up. So again, in this case, all right. Question? Yes.
You have to put the, like when you do 19 divided by 36 on the calculator, you have to put the parentheses in.
Like, okay, hold on a second. Like, when you're typing in the tangent,
Yeah, so you have to put the ending.
do you have to? I mean, so if I hit enter, or if I do it and then put enter, you can see it's going to be the same thing. So I like to put the parenthesis after that, just in case, you know, there's other work that I'm doing. It's a good habit to close the parenthesis. It's a good habit to get into, Jason. But it's not going to, like, mess you up for these kind of problems, okay? Okay. So anyway, let's see here. Let's go to... oh my goodness, what's going on here? So Taylor, all right, so angle B. So if I'm trying to solve for angle B, I have to use these two given sides here. So the 36, what is that in relation to this angle B here, Taylor? Is that the opposite leg, adjacent leg, or the hypotenuse? Opposite leg. And then 19 is the adjacent leg. So which trig ratio are we going to use here to set this up? What has opposite leg and adjacent leg in it? Okay, so let's look up there. So remember our little memory trick there, SOHCAHTOA. So which one has opposite and adjacent in it? Sine, cosine, or tangent? Which one of those has opposite and adjacent in it? Tangent, that's right. So we're going to use tangent. So tangent of y, our angle y there, is going to equal what over what here, Taylor? 36 over 19. You got it. Okay, that's the setup. But of course, we're not interested in tangent of y. We want to know what just y is. So in our calculators, all right, we're going to go y equals tangent inverse of 36 over 19. So it just flips.
So all you have to do is, like, solve, like, put it in the...
You just got to set it up, and then it's pretty much, you're good to go from there, yeah. Okay, so you press second, and then the second button, the blue button, in my case, yours is yellow, and then the tangent button, and that gives you the tangent to the -1, or the tangent inverse command. 36 divided by 19, boom, 62. Actually, we want the nearest degree, so what should we round that to then, Taylor? Thank you. 62 degrees, that's right. Okay, so this one was 28, and this one was 62.
Wouldn't it be 63 degrees? Because of 7.
Well, but the 7 would round this up to a 0.2, but then 0.2 rounds down, so it's still 62. Okay. Now, did anyone see a different way to solve for angle B once we had angle A? How could we have gotten angle B once we had angle B?
Oh, you could have done 19 over 36, right?
Well, so 19 over 36 was what we did to get angle A. That was the ratio. But I'm talking about once we have two angles in a triangle, how can we find that third one? Subtract it from 180. Yeah, we also could have just subtracted from 180. So, all right, let's try another one here. Let's look at number 8. Okay, and it just says to find angle J. So I'm going to call that. We'll call that X. We don't know what it is, so I'll call that measure X.
Why don't we just go J?
We could, I guess.
Kind of silly.
I like to make things more difficult, I guess. All right. Oh, I need someone new here. All right, Garrett. So Garrett, right here, this is our angle we're trying to solve for, angle J. Okay? we have this 46, which is what in relationship to this angle J? Is it the opposite leg, adjacent leg, or the hypotenuse of the right triangle? It's the opposite. That's right. And then what is 93? Derek.
Yeah.
Garrett, what is this side in relationship to angle J? Adjacent. So what trig ratio has opposite and adjacent in it? Right, so it's TOA, it's the tangent. Tangent is what we're going to use. So tangent equals, and it's opposite over adjacent, so it'll be 46 over 93. Exactly right. And again, we want to solve for the x here. We're solving for this angle, so we'll do second tangent. Okay, so it's tangent inverse. Oh, sorry, I called it second tangent. That's the calculator command.
Where's that button?
Right, yeah, sorry. It's the second button, then tangent to get the tangent inverse, right? Sorry, I'm so used to saying the calculator commands there. So it's second button, then the tangent button, gives you tangent inverse, 46 divided by 93, 26 degrees, we'll say. We'll round it to the nearest decimal, or nearest whole degree, so 26 degrees there. Okay? So there's our answer. Questions on any of that? That's it. We're going to look at sine and cosine too, but it's the same setup, same idea. Yeah, that's all we're learning today. That's all the new stuff. Okay? So any questions on tangent? Any questions on tangent?
Wait, yeah, actually, I got a question.
Okay, question?
How do we know when we have to use a negative?
When you are solving for an angle. Anytime you're solving for an angle, you'll use the negative. And here's the thing, Jason. Here's another way you can see. The x is not over here. It's in the tangent. So you have to get rid of the tangent. That's why you use second tangent. Okay? It's where the x is located as well. That's another way you can think about it. All right. Now, if you guys could turn real quick to page 701. 701. That is not on the back of one of your homeworks. So it's in your books. I know we're like jumping around here. I apologize. It's kind of silly. All right. But it's the way things are organized in your book, and I kind of am stuck to that, okay? So, it's better than having to, like, copy down notes by hand, right? I mean, it's kind of some of it's already written for you. You'd rather do that? No, well.
I don't even think I had that.
701. It should be in there. It should be in there.
Should be up. Can we
Okay.
rip it out?
If you'd like to rip it out, absolutely. That's your choice.
Is there any other
I'm sorry, Jason?
Is there any other page you're going to...
I think that's the only one we're going to worry about in this case. Okay, that's the only one we're going to worry about in this case. All right, so thank you, Garrett, for that last one. All right, let's go to Derek. So Derek, we're going to use this triangle now, and we're going to solve for, let's see here. I guess it wants us to find angle A. So let's say we want to find angle A. Okay, so look at what we got here. What is 5, this side, what is this side in relationship to this angle A? Is it the opposite leg, adjacent leg? It's the opposite, very good. And then what is the 10?
Is it the hypotenuse?
That is correct. So which trig ratio are we going to use to set this up then? What has opposite and hypotenuse in it?
Oh, sine.
Sine. So we'll say sine of x equals opposite 5 over hypotenuse 10. Again, right, folks, the x is inside the sign. So, Jason, when we see the x inside the sign like that, that means we know we're using that second sign, the sign inverse, sine negative 1, okay? So, we're going to just say x is equal to sine inverse of 5 over 10. Okay, like so. And we just type that into our calculator. Second sine 5 divided by 10. Hit enter. 30. Well, that's an exact number. That's kind of rare, right? What kind of right triangle does that mean we have here then? It's a 30, 60, 90. And doesn't that make sense? Because look, if this is the 5, that's like the x side, and this is like the 2x side, right? The hypotenuse is twice the shortest leg. And so this one will be 5 root 3, right? AB we would expect to be 5 root 3 if we solve for that one. Okay? But yeah, it's a 30, 60, 90 triangle. Good eyes, Scarlett. All right, let's do another one. Okay, so example 4 here on the next page, page 702. Let's do this one. Okay? So in this one, the directions say to find the acute angle measures in triangle PQR to the nearest degree. Now, we want to find both P and R here. So, Zaria, which angle do you want to look for? You want to solve for first, P or R? Your choice. P. Great. Okay, I'll call that one X. We don't know it. Zaria, we have this side here that's a length of 7. Is that an adjacent, opposite, or hypotenuse? 7. Zaria, please, hang on. So, 7, well, careful, here's this is the opposite. This is the adjacent, that's right. Shh. And then what is the 13 in this right triangle? Very good. So which trig ratio, Zaria, has both adjacent legs and hypotenuses in it? Cosine. So we're going to say cosine of x equals adjacent 7 over hypotenuse 13. Wait, question?
R is cosine of 7.
So we're doing angle P right now.
Oh.
Angle P, that's why I put the x in there. Okay. And the directions it has R first, yeah. We're gonna do P first because that's what Zaria chose, and we can do it that way. Okay. So now what do we do? Now what do we do? X equals. Go ahead, Zaria. Cosine -1, right, of the 7 over 13. That's right. And then we just go to our calculator.
What if you don't have a graphic?
Your smartphone calculators can do this.
No, I've tried it.
I'll come back and take a look at it. It can. I know it can because I've had other students that it worked for. Whoops. Sorry, I want the nearest whole degree, so I guess we'll say 57 degrees there. Okay, so that's 57. Okay, so 57 is that x there. 57 degrees. Now, Zaria, if I want to find angle R, what could I do now that I know 2 angles in my triangle? What's one option that I have for finding angle R there? Since I know 2 angles, how can I find that third one? What do all the angles in the triangle have to add up to? 180. So if I know 2 of them, I could subtract off these 2 and find that third angle. So I could do 180 minus 90 minus 57. And I get 33 degrees. So we would expect angle R to be 33 degrees. But let's actually do that with the trig just to make sure we're right. And then we'll stop and I'll give you guys your assignment, okay? So 33 degrees. We expect it to be 33 degrees, but let's actually try and solve for angle R here. I'll call it like Y, just to change it up. Okay? And let me pick someone to help us set this up. So let's go to Josh. So Josh, if I want to solve for this angle R here, okay, what is 7, that side, in relation to the angle R? Is it the opposite leg, adjacent leg, or hypotenuse? You got it. Very good, Josh. And then 13, what is that? Opposite leg, adjacent leg, or hypotenuse? It is adjacent, but is it the adjacent leg? It's the hypotenuse. That's right. So what trig ratio, Josh, has both opposite and hypotenuse in it? Sine? Yep, we got it. So we'll say sine of Y equals the opposite leg 7 over the hypotenuse 13.
Why is there a Y instead of an X?
Because I used Y for the R, just because I already used X, so I wanted to change it up some. All right, so Y equals then sine inverse of 7 over 13. And so when I solve that, second sine of 7 over 13, we get 32.57, which rounds up to 33, which is what we expected from what Zaria said earlier. If they add up to 180, we'd expect it to add up to, we should get 33 there, and we do. Okay? Questions on any of that? Okay? Hopefully that's a little bit easier than what we did yesterday.